Is it time to rethink the power grid? This question comes from Andrew in Indianapolis, where, when I used to eat shrimp cocktails or shrimp, I don't eat fish anymore, but just veggies. But when I used to eat shrimp cocktails, there was an upstairs place in downtown Indianapolis that had the best damn shrimp I mean, it was like it was a fresh horseradish. That's hard to say. It was man, it was really good. I remember it was sort of famous for that. It was down in downtown Indianapolis. It's only got like two main streets, and there's a row of restaurants and things. But it was really good. I might even have to break my vows of vegetarianism to have that. Anyway, Andrew writes, I recently fell onto your video cast and had never heard of your company before. Oh, I'm glad we were able to reach out to you. I grew up working with the local electrical union, and when we troop a show, I guess set up a show, we carry tons of transformers, and they are in just about everything. I mean, literal tons. I think now to my household again with the death of incandescent lights, and everything has transformers. And of course, what he's referring to there is the proliferation of LED lighting. And I agree with it. I've switched over my entire house, and a lot of PS audio is now switched over to LED lighting, and LED lighting runs on DC. LEDs can't run on AC, so they have to have DC, and therefore, as he's talking about here, I think when he says transformers, he means power supplies, which we'll talk about. In any case, I feel like it's time to reevaluate power distribution. What would it look like to run dual AC split phase into a home and split it into standard service and then a 24-volt DC secondary service through large quality transformers for us by electronic devices? I know this would be a huge shift in the approach to power distribution, but it may be time to start Thomas Edison smiling. Okay, well, for those of you who don't know what that reference is, Thomas Edison smiling, good job, Andrew. He originally wanted the world, certainly America, to run on DC, direct current, which is battery voltage, essentially. And Nikola Tesla wanted the world to run on AC, and Tesla won. And it was not an easy battle. And I actually have Coltrane, if you ever have a chance on YouTube to go see it. It's about an hour long. It was a video service that we produced. It was a whole movie, actually. And it talks a lot about the war of Edison and Tesla over DC or AC. And the crazy thing is, Tesla was right and Edison was wrong for the time. So the problem is DC is not, it's at a specific voltage, and when you try and run it down a long length of wire, like a transmission line that's coming from the power station or the battery sets to various homes, every time a home picks off of it, every time it has to run down a long wire, you start losing voltage, right? So, and there's no way to make that up. So the problem Edison had was when they first electrified New York City, the top floor of a building with DC, the lights would be very dim compared to very bright on the bottom floor. And today you look at a building and that's not the same, right? Every light's exactly the same brightness. And that's because we use AC. And so at the time that was exactly right. The way this works is that AC, I mean, it's still, AC and DC have the same problems through a wire called resistance and converting it to heat. The difference is we can take very high voltage AC, send it down here, and we don't care about the losses. Sure, as it draws current, as the wires go along, the voltage goes down, 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 down. But if you need the voltage down here and we're sending voltage up here, then if it goes down like this, who cares, right? You've still got more voltage than you need. So what Andrew is talking about here is transformers, and that was one of the inventions that Tesla helped bring in, was the transformer, which basically is two coils of wire that magnetically couple AC from one voltage to another. So you have I don't want to get into all that, but you have one coil of wire called the primary, and it makes a magnetic field that comes up and collapses 60 times a second. In this country, 50 over in Europe, in Asia. And on the other side, you have another coil of wire called the secondary, and then that, depending on the number of turns between the primary and the secondary, will determine what the output voltage is. So if I've got 1,000 volts coming in here, and I want 100 volts coming out here, all I have to do is to have 10 times fewer turns of wire on the secondary than I do on the primary. And I'll have a 10-to-1 reduction, 1,000 coming in, 100 coming out. Make sense? DC, you can't do that. DC, if you want lower voltage, you have to burn it off into heat, and that's very inefficient. So the problem we have is very simple. Just about everything in our lives now runs on DC, right? So, I mean, this, I don't know if you can see that. This, here we're sitting at an engineer's desk. All of this stuff here, this DAC, what is that, a DAC? And here's another DAC, and here's a headphone amplifier, and all this stuff, right? This computer, see these monitors? All of this runs on DC, and we have to convert AC to DC. So Andrew is suggesting, why not run DC throughout our house so that we have one central point that you can plug in? Now we kind of do that because if you go to, well, in your car, of course it runs on DC in the first place, but if, let's pick a better example, a hotel room. Many modern hotel rooms have courtesy outlets of DC to plug your phone in, right? 5 volts or whatever. And a lot of stuff today has, these little USB sticks, if you plug it into the back, there's actually 5 volts available on that input. So you can charge your phone off it, you can do all kinds of things and get DC. We kind of started on that. Here's the problem, and there are a number. There's no standard. Some stuff runs on 5 volts, some stuff runs on 12 volts, some stuff runs on 24 volts, on and on and on. And if we were to send DC throughout the house as convenience to run our stuff, we'd have to redesign everything. Everything would have to be redesigned. See this product, this DAC, I think if I remember right, it runs on about 22, 23 volts. Let's call it 24 volts DC. Now it plugs into a 120 or 230 volt line, but inside the transformer, let's see if I can do this without killing myself. Can you see that? See that guy? That transformer, that is converting the 120 volts into the voltage we need. Now, from this point on, it's all DC, right? Well, in order to sell this to you, I did mess that up. In order to sell that product to you effectively, you've got to have your own 24 volt supply. And it has to be convenient, it has to be where you want. So, should we rethink our grid? Yeah, I think we are. And over time, slowly but surely, this will come, and it's a great idea, but it's got a long, long way to go. But a great question, and I do thank you for asking it. I'll talk to you tomorrow. Bye.